Got it. Okay. I'm just trying to let this load. So there, stop this thing. It's gonna feed back on itself. Okay. Oh, I thought I stopped it. Okay. Let me see. No. Because I didn't. I must have hit play. Okay, there we go. I think we're good to go now. And let me get these guys. Okay. It's an interesting name. Let me share my screen. You can start the broadcast, and we'll start here. So no real announcements other than week 1 assignments were due last night at midnight. So week 1.1 graphs with the homework and quiz was due last night at 11:59. But keep in mind that with all of our assignments, we get unlimited attempts, and there's only a 10% late penalty. And homework is only 10% of your overall grade, and your quizzes are only 10% of your overall grade. So with those being late, you miss like 1 point out of 100, I think, something like that, for the entire semester. So it's nothing to fret about. You just don't want to make a habit of missing assignments and things of that nature. Also, as a friendly alert, so exam 1 should become available during week 4. But there are prerequisites for exam 1. The prereqs are that you pass quizzes 1, 2, and 3. So you got to get at least a 70, which is or 4 out of the 5 questions. You have to pass the quizzes in order to access exam 1, right? So you don't want to be trying to wait till the last minute to get those done, because you want to maximize your time, to try to get as high a score possible before the deadline. After the deadline, then the highest you can earn is a 90. Let's see. Also, I would encourage everyone, as you make your way through the homework, make use of the Ask My Instructor. The recommendation is that you're going through my YouTube, watching the lectures associated with each section. You take notes as if you're in class. And so those full lectures should correspond to your homework and quizzes. And then as you make your way through the homework, you want to be as organized as possible. So you want to have a copy. You want to have a copy of each question as you work on it, the original question, and then any supporting work with the final answer in a box. Success in this class, a lot of it is tied to organization, and not borrowing somebody else's organization or notes, but actually making it yourself. A lot of the learning comes from creating it yourself. I know it can be rather time consuming. You just have to prioritize and make a plan. Because if you borrow somebody else's notes, it's not gonna sink in the way it should. And believe me, I've been there trying to rummage through somebody else's notes, and then it didn't do me. It didn't serve me at all. But whenever I made it myself and I actually tried, it was like night and day, so much better. Let me see what else. So make use of the Ask My Instructor. Also, I would encourage you all to work together. So I don't know if you all have a group me or some forum where you all are linked up and you're communicating, but I think that's a good idea. And I think it's also a good idea to seek out the tutors. So hopefully you sought out the tutors. Do what you can on your own, but definitely make use of the tutors that are included in your tuition. You pay for them already, so you don't want to just be giving your money away and not making use of the services. So again, and typically the way I run my classes, these are remote asynchronous. All I need from you guys on any given day is to get into my Zoom so that you got your attendance credit. You're not obligated to stay, but the way I really run the course is class time is really office hours or a study session. So this is the perfect time to get your questions out. And I don't mind going through any assignment that's on Pearson. So if you have a specific question from something on Pearson, we can pull it up and talk about it, get to the bottom of it. If there aren't questions, then I'll either go through as much of the lecture as I can, or I'll go through as many of the homework questions as I can. So if somebody wants me to go through the homework, just say, hey, can we go through the homework? And then I'll stop the lecture, which you already have access to, and I'll go through as many of the homework questions as I can. Let me check the chat really quickly. So I know we have a couple in the waiting room. Yeah, Mr. Hayes. Yeah, let me get this other student. Yeah, So yeah, welcome back, Mr. Hayes. I noticed it as soon as I logged into this course. I saw your name and I was like, oh, he set it in on the wrong class. That was College Algebra 2, which you set in on. So that was like the first full presentation for College Algebra 2. This is College Algebra 1. So there's a lot of stuff there that you're expected to already know that we talked about. So I'm just glad we got to the bottom of it all and you're able to get to where you needed to be. But I do have you on my roster, so you're okay. Will the quizzes be inputted into the gradebook? Yes, the quizzes will go into the gradebook. Let me see. The homework counts for 10% of your overall grade, and the quizzes count for 10% of your overall grade, right? So it's not a heavy weight. The homework and quizzes are really there to kind of prepare you. He has a couple of different accounts. To prepare, yeah, it's okay. To prepare you for, the homework and quizzes are really there to prepare you for the exams where the bulk of your grade comes from. That's okay. So let's see. Okay, so yeah, so my plan is to go through as much of the lecture as I can. But if somebody would like me to go through the homework, you just request it, and you also feel free to unmute yourself. You don't have to like use the chat, but just get my attention and say, hey, can we go through the homework? And we'll do as many homework questions as we can. Everybody is still responsible for doing their homework because it basically it creates new questions for each student. So, even though it'll be the same question, it'll be different numbers. So we can work on stuff together, but you will still have to do it yourself to get the credit. So even though section 1.1 was due last night, I still wanted to take at least one day to kind of go through as much of 1.1 as we can on graphs of equations. And then on Wednesday, we'll go through as much as 1.2, and that should kind of get us caught up. Some objectives here: we want to plot points in a Cartesian plane, find the distance between 2 points, find the midpoint of a line segment, sketch a graph by plotting points, find the intercepts of a graph, find the symmetries in the graph, and find the equation of a circle. So this list is chock full of like formulas that you're going to be responsible for. So again, to position yourself for success in my class, a lot of it is tied to your level of organization. The more organized and neat you can be, the better. And so what I mean is like, you definitely want to have a copy of the full notes. There are some things on my version of the instructor notes that I omitted from you all. So like and maybe I haven't made it available just yet, but I'm going to make the student notes available. And basically what I do is I have like definitions and theorems and corollaries, and then I'll have the example with just the question, but then no supporting documentation. So the supporting documentation is on mine. So you definitely want to do your best to try to get a copy of mine just for an explanation on the notes. But yeah, you want to be as neat and organized as possible. Hopefully you have a notebook where every time you come across a formula, you have a formula sheet that you're creating. So every time you come across a new formula, you update your formula sheet. And so that way, in the future, as needed, might come a time when you might need it. And if you haven't created it, then you can't call on it. And, again, like if you borrow somebody else's, that's not really going to serve you. It might, but it's not going to serve you as well as if you create it yourself, right? So a combination of those. Okay. So with that, let's take some time to go through this lecture as much as possible. I feel like it's fairly light, let's just kind of get going. So we have some definitions. Ordered pair of real numbers is a pair of real numbers in which the order is specified, right? So you'll see things like, this -3, 1. So this is an ordered pair where the order is important. So the first component is our exponent. That tells us where on the x-axis to go. And then this tells us where on the y-axis to go. So this is like our GPS. This is telling us how to get to an address, a certain point on the Cartesian plane. The ordered pair A, B has a first component A and a second component B. So two ordered pairs are equal if and only if the corresponding components are equal. So then the X matches up with the A, the Y matches up with the B. Okay. So some definitions: the set of ordered pair of real numbers are identified with points on a plane called the coordinate plane or the Cartesian plane. So if you take the x-axis, which runs side to side, positive x goes off to the right, and the y-axis, which runs vertical, where the positive y goes up, then it breaks the flat surface up into 4 quadrants, right? So we have this quadrant 1, which is everything going off in this direction. It's quadrant 1. And then if you go counterclockwise, quadrant 2 is everything going off in this direction. Quadrant 3 is the lower left, everything going in that direction. And quadrant 4 is the lower right, everything in this direction, right? So when we put the XY axis on the flat surface in a 90-degree angle, it breaks that flat surface up into 4 quadrants. We refer to the point corresponding to the ordered pair as the graph of the ordered pair. You might hear me call this like, you know, an ordered pair or the location of the point or the address or whatever, but it just means, you know, where on the coordinate plane is that point located. This notation P of AB designates the point P in the coordinate plane whose X coordinate is A and whose Y coordinate is B, okay? I feel like this isn't too bad. So how to plot points, basically, right? So say A is the point 3, 1. So if we start at the origin, we go right 3 and up 1, and you see A there is 3, 1. B says -2, 4, so we go left 2 and up 4, so on and so on, right? And if anything isn't clear, you just have to stop me and get my attention. You know, I'm kind of going through this a little bit quickly because I feel like this isn't too bad. I feel like you can handle it. I'll change the rhythm and pace as we get to things that are a little bit more intense. So we have the Pythagorean theorem for a right triangle. So we have a triangle that has a 90-degree angle. So then the sum of the squares of our shorter leg should be equal to the square of the longer leg. Now, I did have a student in my 9 a.m. that had a really good question from this from his quiz. He said he was working through the quiz. And so that's the Pythagorean theorem. He was working through the quiz and he got to this question about 3 points being collinear. And he said, how do you determine if 3 points are collinear? So I was like, well, there are 2 techniques. And initially, I think I said something along their lines of, you know, you can use a triangle inequality where a squared plus b squared. If a squared plus b squared equals c squared, that was a little bit off, right? So we put it to the test and it was wrong. I was like, wait a minute, let's try to get to the bottom of what's going on. So long story short, when we had 3 points that were collinear, one technique is if you say, instead of a squared plus b squared equals c squared, you say a plus b equals c. So just remove the squares. If a plus b equals c, then that means that the 3 points are collinear, right? Or you can find the equation of the line through 2 points, verify the third, right? Hopefully we can get an example that comes up where we can see this in action. So then the distance formula between 2 points, this comes out of the Pythagorean theorem, right? So notice, if we consider 2 points, P and Q, right? And we want to find the distance between P and Q, right? So now we have this third point S where the X coordinate comes from P and the Y coordinate comes from Q, all right? So we can use Pythagorean theorem here where we will let this be our A, let this be our B, and let this be our C. So then the distance between the X values here is going to be the absolute value of X2 minus X1. The distance between our Y values here is going to be the absolute value of Y2 minus Y1. So if we say this squared plus this squared should equal this squared, right? So then if we take the square roots on both sides, and because absolute value is positive, we can lose the absolute value and change it to parentheses. That's where the distance formula comes from. So the distance formula is an application of the Pythagorean theorem on the Cartesian plane. You don't need to know that backstory. I'm just giving you backstory for context. But you don't have to know that. This formula here, I would definitely include this on my formula sheet. So this is one of those formulas that I would include. I feel like this other one is simple, but it doesn't hurt to have that either, Pythagorean theorem, right? So Pythagorean theorem and the distance formula, these are 2 formulas I would include on my formula sheet, okay? This was just backstory on where the formula comes from. You don't really need to know that. You just need to know how to use it. Let me pause for a moment there and let's check the chat really quickly. I think we got people dropping off, but that's okay. That was the agreement. Let me get this student. That was the agreement because I know it's intense. And so I just want you guys to get through it however you need to. This presentation will be This presentation will be on my YouTube. I will say that though, it's a lot of information on there. I do typically live stream these sessions, but then you'd have to comb through and like find your specific class, you know, which is nothing wrong with it, but there is a copy that's available, right? So in this example, we're asked to find the distance between these points. Now let me see. We do have a whiteboard. I'll do this one for right now. I'll do it for right now. Find the distance between the 2 points. So my recommendation, every time we use a formula, you want to write it down, right? So in this case, the distance between P and Q, that's going to be the square root. We're going to say x2 minus x1 squared plus y2 minus y1 squared. Okay. Can we clean that up a little bit? That's fine. And then also what I like to do whenever I get ordered pairs, I like to just automatically label them. This is my x1, y1. This is my x2, y2. I just like to, it just makes it easier for me. So then what we want to do is basically just plug in the corresponding parts into the formula. So the distance between these 2 points is going to be the square root of, now our x2 is 3 minus x1 is -2. Notice my use of parentheses. My y2 is -4 minus y1 is 5. Okay. So then 3 minus -2, double negative there is positive. That becomes a 5. 5 squared is 25. -4 minus 5 is -9. -9 times -9 is a positive 81. So what is that, 106? Okay. Hopefully we're all aboard and we're not all bored. And if there are any questions, you know, again, you just have to stop me and get my attention. Okay, let me check the chat really quickly. Chat looks good. Okay, I'm not gonna worry about it. Okay. So when we did it just now, we got a result of the square root of 106, right? And then you can just use your calculator to approximate that. But you see it in the bottom right-hand corner, square root of 106. Okay. So then now we have the midpoint formula. So this is another formula that if you had a formula sheet, you definitely want to just go ahead and update it with this. I would put like an M here just so I know that we're talking about the midpoint between those 2 points. And the way I remember midpoint is basically the average of my x's, comma, average of my y's. So you want to find the halfway part or the middle. So midpoint for me is average of my x's, comma, average of my y's. Okay. So find the midpoint of this line segment. So let's write the formula again. One of my professors suggested every time you use a formula, write it down. So the midpoint between P and Q, and again, I personally like to label x1, y1, x2, y2, and the midpoint is average of my x's, comma, average of my y's. So that's how we're going to find the midpoint. Okay. So the midpoint for between P and Q, that's going to be -3 plus 1 over 2. And then that's going to be 6 plus 4 over 2. Okay. I think that result is ultimately -1, comma 5. Okay. So like what you see on the screen is indicative of like what you should be having in your notebook. You have a copy of the original question, any supporting work, and your final answer in the box, right? Let's see. And now we could plot these to look just to confirm, but we have it worked out here. -1, comma 5. Okay. Let me see the time. Man, for some reason, I am fading fast. I'm so like, I don't know. I think I'm just getting older. Okay, let's keep going. So an ordered pair is said to satisfy an equation with variables a, b if when a is substituted for x and b is substituted for y, the resulting statement is true. An ordered pair that satisfies an equation is called a solution, right? So, you have an equation and you say that is this ordered pair a solution? When you plug in the x and the y, it should make the final result true. And then frequently the numerical values of the variable y can be determined by assigning appropriate values of the variable x. For this reason, y is sometimes referred to as the dependent variable and x is the independent variable. Again, oftentimes, we often choose values of x and then it outputs some value for y. So the y value depends on the x value. So typically we call the y value the dependent variable and the x value the independent variable. The graph of an equation in two variables such as x and y is a set of all ordered pairs in a coordinate system that satisfies the equation. That's just a set of all the solutions. So here we're asked to sketch this graph. And so basically what we're doing is like, we chose these x values on the left and we just basically finding the corresponding y's and then plotting the points. I'll just do a few of these quickly, right? So we're gonna get our y values over here. So for instance, when x is -3, then our y is going to be equal to -3 squared minus 3, which is 9 minus 3, which is what? 6. So it looks like that one is 6. Let's do this one. Y equals, so -2 squared minus 3. That's what? 4 minus 3 is 1. I want to show you something once we're done with this. So we have y equals -1 squared minus 3. So 1 minus 3 is -2. Okay. 0 squared minus 3. So that's -3. Now, we wouldn't talk about that yet, so can't say that. Y equals 1 squared minus 3. So it's going to be -2. 2 squared minus 3. That's going to be a 1. 3 squared minus 3. 6. Right? I just want to show you some of the capabilities. Now, you don't have to use this next item. Let's see if I can get it to come up. Hang on. So in the past, if I can get it, yeah. In the past, it was recommended that you use a graphing calculator. I'm just trying to get I have a virtual one here. I'm trying to get open. And I got to reload it, agree, choose the file. I got to go way, way back. It's going to be here. And it should be, is it that one? Okay, that looks good. Reload and refresh. Okay. So then, actually, let's break this one off. Let's do it like this. Okay. Using a TI-83 Plus emulator, because this is the calculator that's generally recommended for like this kind of work. But since we're remote asynchronous, you can also use like GeoGebra for digital graphing. It's free online graphing software. It's called GeoGebra, GeoGebra. It's really weird. It's like geography and algebra. It's called GeoGebra. Another one is called Desmos, DESMO something. MOS something, but it's another free. If you just do a Google search for free graphing software, then you can get graphs for free, right? But I'm just gonna do a demo on the TI-83 Plus. Now we did all of this by hand, right? It's nothing wrong with it. So now I'm gonna go to my y equals, and I'm gonna put in x squared minus 3. So x squared minus 3, okay. And then I want to go to my table. Now I'm gonna go to my table set. I want the table to start when x is -3, and I wanted to change by 1, okay? And then I'm gonna hop over to the table. So now what I did, I made a table. You see the -3, the corresponding X values, and it should match our Y values. 6, 1, -2, -3, -2, 1, 6, right? You could have also done this in Excel. You know, Microsoft Excel allows you to do stuff like this as well. You can type in formulas. Yeah, so I just wanted you to see, like we did it by hand, but then the calculator can do it as well. I just wanted to make you aware of that. Let me check the chat really quickly. Man, my stuff is just like throwing a tantrum for real. Okay. Suppress. I think the chat looks good. Okay. So, you know, we saw this in let's see. Okay, that looks good. So we saw this in the TI-83 Plus. Again, you can also make a chart in Excel using formulas, things of that nature, right? Oh, and then they had the order pair, but that's fine. Okay. So then if we take those ordered pairs and plot them, we'll get an image like this. Now we can even see this in the graphing calculator. Let's put it here, side by side. All right, so we can see it here. So if I just hit on a graph, I think, on Windows fine. And if I can get it to work, okay. And I'm gonna turn stat plot on. I think the boxes are fine. Okay, so now if I go to graph on X1, X2, check my table. Invalid dimensions. Stat plot. I'm not sure. Okay, let's do the table set maybe. Okay, here. Let me see if I reload it and see if that'll, because I'm not sure what I'm doing wrong for that not to show. We got y equals x squared. I think it's because I did the table. I changed the table. I think that's what was causing it. So now if I go to graph, right? Let me check the table really quickly. Okay, now if I go to stat plot. Oh, because I didn't put anything here. Okay. Okay, that's what it was. Okay. I mean, I don't really feel like typing those out, but we can plot those points here and they will show up on the graph as well. Trying to think if there's a faster way to go about it. You know, but if we, you know, if we typed all those in, I think I could type here. So we did what? -3, -2. Go to -3. Let me see. -2. Oh, that's the wrong 2. Okay, go to. So instead of that one, does this one work? -2. Okay. -1. Now we're flowing. 1, 2, 3. There we go. And then I think we got what? 6, 1, -2, -1, 0, 1. Nope. Back up. I was putting the wrong stuff in. 1. Okay. -2 is good. -3 is supposed to be there. So then -3, -2, 1, and 6. Okay. So now if we go to stat plot, if we turn it on, because we didn't have any data last time, that's why it wasn't working. So it plots those points and sends the graph through it, right? So that's on a TI-83 Plus. Just showing you the capability for your awareness, okay? Okay, so we did that one. Let's keep moving. I think you all's group was the first group that I did that demo with. I haven't done it with anybody else today. Sketching a graph by plotting points, right? I think that's what we essentially did. We made a representative table of solutions of the equation. So we had our equation. We chose some x values. We found the corresponding y's, and then we plot the solutions as ordered pairs in a Cartesian plane. And then we connected those points in step 2 with a smooth curve, right? So that's the first way that we have for graphing. Any point where a graph intersects the x-axis has the form a comma 0, where a is a number where a is called the x-intercept. So on the x-axis, y is always 0, and on the y-axis for the y-intercept, x is always 0, right? So you should have come across that by now. So to find the intercepts of a graph, to find the x-intercept, set y equal to 0 and solve. To find the y-intercept, set x is 0 and solve, right? So find the x and y intercepts of the graph. So now for me, I feel like it's oftentimes easier to find the y-intercept than it is to find the x-intercept. So I usually encourage people to find the y-intercept first. Okay. So in order to find the y-intercept, we set x equal to 0 and solve. All right. So then our y-intercept is going to be 0 squared minus 0 minus 2. Notice this term goes to 0, this term goes to 0, and I think we're left with negative 2. So this is our y-intercept. And then for the x-intercept, we set y equal to 0. Okay, again, if I'm going too fast or anything, you have to just stop me and get my attention, and we can talk about any of the stuff. I'm just trying to keep myself awake, and I'm just here. I'm just filling the air. We don't have to do this. I'm just filling the air with pertinent information. So now if we set y equal to 0, so I know I had a student that asked about something similar over the weekend. Hopefully you all are making use of the Ask My Instructor. It'll send me a screenshot of your question and we can talk about it. So for this course, you are expected to have some level of proficiency with factoring, right? This is a trinomial. Now, let me bring this following document to your attention. So if we go to our landing page, that's fine. If we go to our landing page on Blackboard, so this is what, College Algebra 1, this one. So open up our folder, and let's see, that's YouTube, those are the assignments. So I used to have a handouts folder. It's going to be in this item number 3, the lecture slide. So if I open that up, it's going to take you to a box, and right here in item number 4, it says handouts. If we open that up, there's this, I have a few documents here. Really, it's the main 2, which is on factoring, and the second one says how to approach a factoring problem. That first document is an entire chapter devoted specifically to factoring. I'm gonna let that be for now. But this is the one that I wanna bring to your attention. How to approach a factoring problem. Let me share to Notability. I think it's this one. The 2 p.m. Let me see the time. We got a solid 10 minutes. Let me import. Let me hop back over there. Okay, this is slide 21. This one. Let me cut. Go back here. Paste. Okay. Actually, let's move it down some. Finding intercepts. Okay. All right. So again, with this example, we are factoring, and it is expected. We do expect you to already have a level of command of factoring. This one does not have the lab, so whenever we're approaching a factoring problem, this is like the questions that we want to ask ourselves. First, we ask ourselves, is there a greatest common factor, a GCF, right? So then once you go through your GCF or your greatest common factors, then you're going to have, we typically have one of three cases. We say, okay, how many terms do we have? Are there 2 terms, 3 terms, or 4 terms? In the case that we're working right now, we have 3 terms. Terms are things that are added and subtracted, right? We have 3 things that are being added and subtracted. So we're working in this case here where we have a trinomial, and it's really this first one. So we can jump straight to the double parentheses, right? But these are the questions like, okay, that you want to ask yourself when you're factoring, this is how we approach a factoring question. So then here, it looks like we might be able to just jump straight to this form, right? Where we have x and x. Notice our leading coefficient is a 1, so we don't have to do anything funky there. We're looking for 2 numbers that multiply to give us -2 and add to give us -1, right? So I think those 2 numbers, -2 and a +1. Notice that -2 times 1 is -2. -2 plus 1 is -1. So then from here, you have the 0 factor property. When 2 or more things multiply to give us 0, you basically set each thing to 0 and solve. So you either x minus 2 equals 0, and we have to include the other one, which is x plus 1 equals 0, and solve those corresponding equations. So 0 factor property, when 2 or more things multiply to give us 0, we set each factor to 0 and solve. Here we get x equals 2, x equals -1. All right. So those are our x-intercepts. Okay. So let's see, how do we do? To find the x-intercepts, I think we said 2 and -1. We got those. And then the y-intercept, we said x is 0, we got -2. And here's just a graph. You see your x-intercepts here. You see your y-intercept here. Okay, let's try to stay on for like another 5 minutes. And again, just stop me if you have questions, or if you let me kind of check the chat really quickly. We see originally starting to Zoom at 156. Kick me out because of the time. That's fine. That's fine. It's no worries. Yeah. So as long as you make it into the Zoom, that's the main thing. I haven't really been doing like late and all of that. Let me just make sure. And again, usually I take attendance as I let you guys in. So if you're in, it shouldn't be any trouble. Yeah, I got everybody. Everybody that's in the Zoom has attendance credit. You were on my roster and everything. Okay, let's just take a few more minutes to go a little bit further. So symmetry, right? The symmetry means that one portion of the graph has a mirror image of another, right? So the mirror line is called the axis of symmetry, or a line of symmetry. Right? So this is like if we cut it in half, they're going to match up. So we say a graph is symmetric with respect to the y-axis if every point x comma y on the graph, the point -x comma y is also on the graph, right? So if we're looking at this image, if we were to take this and fold this in half on the y-axis, the left-hand side is going to match the right-hand side. So again, symmetric about the y-axis, whenever we have x comma y, we're also going to have -x comma y. It's like our x's change, right? The y stays the same, but the x's change. So if we have y-axis symmetry, we can also talk about x-axis symmetry, right? So x-axis symmetry, if you fold the graph along the x-axis, they match up. Whenever we have x comma y, in this case, the y should change. Let me see, I think x-axis is next, all right? So x-axis, whenever we have x comma y, we also have x comma -y. Now, that's what we mean by x-axis symmetry. And then lastly, we have symmetry with respect to the origin. So origin symmetry is like whenever we have x comma y, they both change. Both x and both y, they both change. So whenever we have x comma y, we also have negative x comma negative y. Right? And so origin symmetry is going to be kind of like this, where they're going to be symmetric about the origin. You're going to have points that are the same distance or symmetric about the origin. Okay. So determine whether the graph of the equation is symmetric with respect to the y-axis. So if we're doing a test for y-axis symmetry, that means we got to change our x and negative x and simplify, right? So the test for y-axis symmetry, we change x to negative x, simplify. If we get back to the original, then that means we have y. It's a yes. If we don't get back to the original, then it's not. All right. So let's see this one in action. So we want to test for y-axis. So let's do this. So for y-axis symmetry, we want to change x to negative x and simplify. Okay. So we're going to switch out this x in just a moment. All right. And we say change x to negative x. So now if we're working with this guy, negative x times negative x is a positive x squared. And I think everything else is the same, which is the original, right? So then does this have y-axis symmetry? This is a case where we would say yes. Again, we changed x to negative x and we got back to the original. So then that's a sign. That's how we test for y-axis symmetry. Let's go a little bit further. Right? So we changed x to negative x. We got back to the original. There's a typed up explanation. Test for all three symmetries. And we have this 4x minus x cubed. Okay. For the sake of time, I'm just going to go ahead and rely here on the notes that are already prepared. So we have this 4x minus x cubed. If we wanted to test for x-axis symmetry, we got to change y with negative y. So if we change y with negative y, we get this. Now, even if we multiply both sides by a negative, notice that this is not the original. So we do not have x-axis symmetry. For y-axis symmetry, we change x with negative x. And after we do this substitution, again, we do not get back to the original. So that's why we do not have y-axis symmetry. But for origin symmetry, not only do we change x, but we also change the y. So if we change both through algebra, you'll see that you're going to be able to get back to the original. So we do have symmetry with respect to the origin. All right? Let me see. We're kind of out of time. Okay, so then if we want to plot this using symmetry, so if we have symmetry with respect to the origin, that means that whenever we have x comma y, we also have negative x comma negative y. So, you know, we let when x was 0, and then we just chose these x values, found the corresponding y's. But then if we have all of these ordered pairs, we also have basically, you flip all of these signs, and you have all those points as well. So here are the points that we chose. We chose x with the corresponding y. We get all of these guys. But then you're also going to have the opposite sign of those. So it's going to be something kind of like this. All right. So using symmetry. If you basically create more points where you flip the signs, you get the rest of that graph. Okay. Okay. So that's actually a good time to stop. We got up until the part where we talk about circles. I want to say that the discussion of circles is on my channel. I think I went back and made sure to go through that entire section. I think I did. So it should be available on my YouTube. Are there any questions before we go our separate ways? You guys have any questions? Feel free to unmute yourself or type in the chat. Let me just check the chat really quickly. I think the chat looks clear. Okay. So if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. I'll see you guys on Wednesday, same time, same place.
Thank you, Professor.
Yes.
Excuse me, sir. So I was wondering about the assignments itself. So we find all this on Blackboard, right?
I mean, just a quick tour.
Yes, sir.
So if we go to our Blackboard landing page, let's see if I can get this to work. So when you log into Blackboard, you land here, you open up this folder. Come on. You open up this folder, and then our assignments are going to be in this folder number 4. It says assignments. You open that up. And then the first item where it says My Math Lab All Assignments. When you click on that, you're going to be prompted for payment. I think the payment is like just under $120. This is College Algebra 1. So the thing is, with Pearson, if you take a course like, say next semester you take College Algebra 2, if you take another course that uses the exact same book and you use a Pearson, which I teach, you don't have to purchase Access again. I use this same book for at least 3 of our classes: College Algebra 1, College Algebra 2, and Pre-Calculus. I think I use it for Pre-Calculus. So at least 2 classes and potentially a 3rd class, if you're taking it with me, you can use this. You don't have to purchase Access again, right? As long as we're using the exact same book, right? So hopefully that serves you. Okay.
Yes, sir. And so once we purchase that, that's where all of our assignments will be.
Any other questions before we go separate ways? Any other questions? Going once, going twice? Okay. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of the day, guys. Take care. Peace.